Okay, so there are 3 ways to solve the system. First way, graphing. We did that Friday. Today we're going to use something called substitution. We just did that number string, or we just had the warm up, where once you had something, you substitute it in for other things. That's what we're doing today. Good question. Okay, so in this first example, everything today, even though we are not graphing it, everything today is where they would cross on the X and Y axis. So everything today, when we give a solution, it is an ordered pair. Everyone look at me. You write your answers as an ordered pair because it's technically where the graphs intersect. This first one's set up pretty nicely for us. You're solving for X and for Y. Our answers in ordered pairs. This is nice because we already know the Y value. The Y value is 6. Well, since you know the Y value, how could you get an X value? By solving with substitution. If you know this is 6, it's just like those R problems, R and B problems you're just doing. If you know that Y is 6, put a 6 in for that Y. Now solve the equation. 2x plus 6 equals 12. 3. X would be 3, correct, because it would subtract 6. Divided by 2, so X is 3. So if you were to graph these 2 lines, because those are 2 lines, one of them is horizontal, the other is just a slanted line. If you were to graph those 2, they would intersect at the point of 3, 6. Ordered pair, 3, 6. Okay. We're going to save these next 2 examples in just a minute. We're going to do in just a minute. Go to the back of this front page. We're going to look at number 1. Every single answer today is an ordered pair. Nice thing about number 1, it tells you what X equals already. X is -2. That means 0 work. We already have half the problem done. Take what X equals, plug it in, substitute it in the other equation to solve it for Y. So that would be 4, but instead of X, it's times -2 minus 3Y equals 18. Do we now have an equation with just one letter? Yes. Yes, solve it. So it's -8 minus 3Y equals 18. Adding 8 to the other side. So it's -3Y equals 26. Yes. Divide by -3. Yeah. Do those divide? Does that divide nicely? Yes. Can you simplify it? No. So -26 over 3. That's okay. This is the exact reason why we have a different way to solve it other than just graphing. If you were trying to graph this to find the solution, you wouldn't know that exact ordered pair because it wouldn't be on those nice crosses for whole number answers, which is exactly why we have to do this, or why there's a different way to solve it. The answer of, I can't tell what point that is, isn't going to work. You can have this way to solve it also. Okay, let's do the problem right underneath it. So this is now getting a little bit more similar to those R and B problems. Do we have the exact X or exact Y value? No. So we still need X and Y. We need to solve for both of them. Do you have a letter that's by itself? Yes, what letter? X is by itself in that second equation. So what that means, you can take what it is equal to, so the other side, and it plugs in for X in that other equation. So 2Y plus, so I'm rewriting that top equation, but instead of X, I am substituting in the purpose of substitution. Did we just create a different equation with just one letter written in there? One type of letter, either only X or only Y? Yes. Yes. That means this is solvable now. We can now solve combined like terms, get a value for Y. This would be that 5y equals negative 15, which means your y value is negative 3. Wonderful. Okay, you got a y value. Every answer is in ordered pair, so you need an x and a y. So we're missing x still. How could you solve for x? Yeah. Right here, it says x is equal to 3 times y. Okay, well, we just got a y value, right? So 3 times negative 3, what's our x value? Negative 9. We're solving as if we were graphing these two lines. This is where they would intersect without having to do the work of graphing. Okay, let's do number 4. Go across, do number 4. Do you have a letter by itself? Yes. Okay, which letter? Y. Y is by itself in that first equation. That means y in the second equation is getting replaced. It is being substituted with that other side of the equation, that expression of the negative 3x plus 5. So we're rewriting that second equation, which is 5x minus 4, but instead of 4 times y, it's 4 times negative 3x plus 5, and then equals negative 3. How to check if substitution just went well? Do you now have a new equation with just one type of letter written in there? Yes. Yes. It's just y, so that means this is a solvable equation. Distribute, combine like terms, be careful with all of that stuff. That's going to be the part that throws people off. Are we good so far? Yes. Then what? Add the 20? Okay. Add the 20, so that would be 17, the negative 3 plus 20? Yeah. So what's the x value? 1. Okay. Answers are always word pairs. Because it's where they would cross on the graph. 1 is the x value. We still need the y value. Use the number we just had. We got 1 for x. Use it in one of your two equations. Which equation would be easier to solve a y value? The top one. Because that top one is just that negative 3 times x plus 5. So that means negative 3, we just got the x1 plus 5. What's the y value? 2. You could always check your work by actually graphing them if you wanted to. Okay. I want y'all to try number 6. So do the problem that's below the one that we just did. Y'all do number 6. So go back to the front page. Where this is going to get a little bit different, or like getting more difficult, I guess, because we're progressively getting a little bit harder. Examples like this one, example 2. To be able to substitute, you have to have one of the letters by itself. You have to have an equation that says x equals, or you have to have an equation that says y equals. One of your equations has to be set up like that. Example 2 doesn't have that. So that is an added step before you're allowed to substitute. Get one of the letters by itself. Look at your two equations. You can pick whichever equation looks easier to get a letter by itself. Which one do you think works? The second one? Okay, what letter do you want to get by itself on the second one? Y. How would you get y by itself? Add x. So that would be x plus 3. All you need to do is rewrite the equation to get y by itself. Now you have a letter by itself, which means it is now turning into exactly like those other problems we were just doing. Whatever that letter equals is what goes in to that other equation for the letter that was by itself. So x plus, but instead of y, we're writing it as x plus 3 equals 5. How to know if you substituted correctly? Because you have just one letter in the equation, it's one type of letter. Yes, so now it's solvable. Combine our x's to get 2x plus 3 equals 5. Then what? Subtract 3, so 2x equals 2. Therefore, x equals 1. You always need 4 to pair answers. X is 1. How do you now get the y value? Plug it back in. We know that x plus y is 5. If x plus y is 5, and we know x is 1, what does that mean y has to be? 4.
Or you could just plug it into the other one.
Correct. You can plug it into whatever. Yeah. Whatever will get you the answer. You have a lot of equations to choose from. Okay. Let's practice another one similar to that. Example 3. Do you have a letter by itself? No. So that is the goal first. Get a letter by itself so you can substitute. Which equation do you want to work with? The first one, which letter do you want to get by itself? Because remember, it could be x or y, it doesn't matter. Y? How come you're choosing y? Okay. It has a coefficient of a positive 1. Like there's no number visible in front of it. So it requires only one step to get y by itself. What's the one step? Subtract the 2x, so that'd be a negative 2x plus 1. Okay. What letter do we just get by itself? Y. So since y is by itself, that means y is getting replaced in that second equation with this. 4x plus 2, and then 7 times y times negative 2x plus 4 equals 8. Are we good with that substitution? Okay. Distributing. 4x minus 4x plus 8 equals 8. Oh. Why are we making the sound effect? Oh. What happens with these x's? They cancel each other out. Yo, we've talked about solving equations where that happens.
Infinite, right?
Okay, we have our two options. Option 1 is infinite. Option 2 is no solution. Why is this one infinitely many solutions?
Because they correct line.
Okay. So before we move on, yes, what you would box would be infinite solutions, infinitely many solutions. That would be wonderful. Why? Emily? Okay. We're graphing two lines, right? How is it possible when lines intersect? How is it possible for the two lines to intersect infinitely many times? They're the exact same line, right? This is a scenario where they're the same line. I'm going to have you all write down a vocabulary word. A vocabulary word is called coinciding lines. That means they're the same line.
Coinciding.
It just means they're the same line. You're going to see that phrase or that word for coinciding lines. You're going to see that throughout some of our notes or just practice problems. So I want y'all to be familiar with it. Okay, go to the next page. Where we were before. Let's look at number 2. Okay. Steps for substitution. Do you have a letter by itself? Yes. That means that bit of work we don't have to worry about. Which letter is by itself? That means y is getting replaced in the other equation.
What are you saying? Oh, it's another one of these another solution.
Oh, y'all are working ahead? Okay. Are you seeing something that's happening? Not 8 equals 4. So, something similar to what we just did. The variables cancel out. We're left with this statement, negative 8 equals 4. That means no solution. Excellent. We know that that's what that means when we went back to solving equations. What does that mean about the two lines? Because remember, these are two lines.
They're parallel.
They are parallel lines, correct.
Not quite.
They're not swinging.
They are parallel lines. So, what is the difference when you solve the equation? What makes them parallel versus coinciding?
If the numbers
Hold on.
equal each other, they're
Put up.
When it's parallel, the ending like equation doesn't make sense, and then like coinciding line is like.
Okay, perfect. Variables cancel. If it doesn't make sense, it's parallel. If it does make sense, if it's true, then it is infinite solution. They're coinciding lines. Okay. Let's look at the last problem we haven't done from this page yet. Do you have a letter by itself?
wow.
Do you have an equation that says either x equals or y equals? No. So this is a problem where you have to first do that work. Which equation do you want to use? First or second? First. And what I'm going to have us do, I'm going to tell us what letter to get by itself. We're going to get x. Because what tends to happen, y'all are so used to getting things in slope-intercept form, you're allowed to get x by itself for substitution. Sometimes that is the easier letter. Like, there are going to be times where I'm going to look at y'all's paper, and you have crazy fractions all over the place. And if you just would have gotten x by itself instead of y, you wouldn't have all those fractions. So just don't forget that you could just get x by itself also. Just don't forget it. It doesn't matter which letter is by itself for substitution. It just has to be one of them. So if we got x by itself, that means x is being replaced in that second equation. So 3y plus, then negative y plus 3
Oh my god.
equals 11. Combining like terms. Two steps left to solve that. What's first step? Subtract 3. Then what? Divide by 2. Real quick, how do you always write your answers? Ordered pair. Y is 4. What's the x value? Negative 1. If you look back at this, x plus y equals 3. Or x plus y equals 3. So if y is 4, that's how you know x has to be negative 1. You could have done that negative 1 by lots of different equations for both can, that's fine. But just use whatever number you get for the first letter you solve for. That's what you use to get the other letter. Okay, which means, everyone look at me. Since you are solving and whatever your first answer is what you use to get the second answer, if you make a sign mistake, a silly mistake on that first set of problem, or like first set of work, you've automatically missed the second answer. You've already automatically messed it up. Take your time, be careful with distributing, be careful with negatives, multiplying, all of that stuff. Okay. Y'all are working on that.